Have you ever noticed how some college students or the college graduates really get a great marks and scores really well in the exam, but then when it comes to the solving the real world problems or actually using it in the real life, what they have learned, they often struggle, isn't it? Honestly, this is the main reason why good companies, especially in AI or the data science, often prefer the experienced candidates over the freshers, right? So if you are someone who are about to finish the college, or if you are already graduated and still trying to land a first grade job, this video is for you. Yes, today in this video we're going to talk about what is missing in our college education, especially here in India, and most importantly how you can fix that gap and become truly ready for job. This video is not about listing specific technical skills, it's about something deeper. In this video, what we're gonna learn is how to think like a pro, right? It's all about learning how you can think like a professional. Right? You're watching a video from ByAIte presented by Santosh. So let's get diving. Let's make this video a bit interesting. We will consider few sample use cases and try to see what's happening behind, right? Say for example, you are in a jungle and a tiger saw you and it started chasing you. What you will do? Obviously you will run, else the game is over. Assuming that you don't have any weapons in your hand, right? You will run or else the game is over, right? So if a tiger is increasing the running speed, so you will need to increase the speed as well. Again, I know it's not possible to escape the chase from the tiger, but let's assume for now you are capable enough to run faster than the tiger. Let's think of like you have a super ability power, supernatural running speed. Okay, so here the important point I would like to highlight: if the tiger quickly increases its speed, you will need to increase your speed faster than the tiger, or you will get caught, right? Makes sense, isn't it? Your brain is constantly telling your legs to how fast it go, right? Now, here is the thought challenge. How would you explain what your brain is doing mathematically to control your speed, right? Pause the video, think about it, try to connect this with your academic learning, that what you have learned in your college, what you have gained from your college, right? Let's break down simply and see if you are thinking in the same direction or not. Okay, so once the tiger saw you in the jungle, that initial velocity or initial speed of that particular tiger is 0, and even the moment you see the tiger, the initial at the very first very 0th second, right, your velocity, your speed also 0, right? Once you realize that the tiger is there and it will start chasing you, in the first second what you will do, you will start run, right? But tiger also start chasing you. So that let's assume that a tiger goes with 5 km/h to chase you and you go with 10 km/h. When this happened? In the very first second. Okay, in the next second obviously the speed will increase, it will not be same as the first second, right? In the next second, in the time, right, the tiger goes with 10 km/h and you go with 15 km/h, and the very next second what happens? Still tiger will increase the speed to 15 km/h and you will go to 25 km/h and so on, right? You're speeding up so quickly such that your speed needs to be more than how fast the tiger speed is changing, right? If not, you will get caught, isn't it? So if I speak mathematically, this means that derivative of your speed must be greater than the derivative of that particular tiger speed, right? So why I'm telling all this useless story? Because the most of the graduates can easily tell me, if I ask like what is the derivative of x square or what is the differential of x square or a sin x or cos x, they can easily tell that particular answer. Even they can solve the complex differential equations, right? But many of them struggle to explain the real meaning of the derivatives or how it connects to the real world problems like this, right? This example is all about differentiation. If you truly get how it works, its core, you can apply it very smartly in your real life problem solving, right? So with this similar way of thinking, right, connecting the math that you have learned in the academics to the real life situations, this is how the people build the amazing things like self-driving cars or the features like ADAS. I'm talking about the advanced driver assistance systems that we usually seen in the recent cars. ADAS we call it as, right? So that helps to stay the car in a constant speed even though you're not driving it or you're not controlling it, right? Even it's uphill, even it's a downhill, the speed remains constant. How it is constant? Because it will accept that feedback mechanism that is there part of that ADAS system. So it will keep control of how it needs to adopt that particular speed, right? So these complex problems become solvable when you learn to apply what you know, not to just remembering what you learned, right? Let's see one more example. Imagine you want to create a small component in your phone, Photos app, probably you are building it from scratch, let's assume. So there is a small component, you need to develop it or you need to implement it. It should blur an image, it should blur a given image automatically, right? Why? This could be used to hide some messy background, we don't know it. Say for example, for a given image, it should blur it, okay? Then if you change your mind, if you click on the reset button or something like that, it should unblur it and back to the original how it is, right? So now again pause the video, think about it and how you can map this particular problem to the math that you learned in your college. Okay, let's simplify. Here is what we needed, right? Input as an image and output should be blurred image, right? And there should be a way to get the original image back, right? Now in math, an image can be seen as grid of numbers, isn't it? So this is basically a matrix. Let's call our image as a matrix I. To blur it, we need a special blur function. We can also think of this blur function as another matrix. Let's call this blur function matrix as a T, okay? So to get this particular blur image, right, we simply combine the image and the blur function. Mathematically, it's like multiplying them, matrix multiplication I'm talking about, right? So you can see on the screen now, so Bi is equal to I matrix multiplication of T, right? So where T is a blur function, right, and I is the image matrix. So this looks simple, but it is very important. Most of the students know how to multiply the matrices, but you can, they are able to calculate the 2 by 2 or 3 by 3 or no matter how complex that particular matrix is, they are able to do the matrix multiplication easily. Academic students I'm talking about, but many of them struggle to see when to use the matrix multiplication to solve the real world problems, something like blurring an image, right? So basically here I want to tell, like, most of the people, they know how to do it, but they don't know when to do it or why they are doing it, right? This means they have some skills, but lack of ability to connect those skills to the real world task, right? So this is why the many freshers, right, many fresh graduates struggles to solve the actual problems in the job. So that is where the experienced folks are filling the fresher jobs as well, right? So again, now a follow-up question. How do you get that original image back from that particular blurred one? Think again, and now let's see. If Bi equal to T times of I, the blurred image is the multiplication of the transposed, the image and the, the blur function, which is the T matrix. To get back the particular original image, we need to undo that particular blur, right? In math, we use something called as inverse of matrix, if you remember it, right? So what I have to do, I have to find the inverse of the T matrix, and I need to multiply that inverse of the T matrix to the blurred image that will give me the original image that I have given. So if you take the blurred image and multiply with the unblurred matrix, which is the inverse of the T matrix, and you will get the original image back, right? Even if you know how to calculate the matrix inverse, meaning like I have seen many people, they are very good at calculating the matrix, matrix problems and matrix algebra, they are very good at doing that. But the real trick is knowing when to use it or when to apply this particular math in real life. Again, right, it's not just about the matrices or the derivatives or the programming or the coding, it's true for every foundational concept that you learn. Right? Now we will see why does this gap exist in our education system, right? We will see the reasons, top reasons as per my understanding or as per my research, okay? So in the college, we have too much theory, not enough practices, right? Colleges often teach a lot of theory, but do not give enough real world problems to solve it. You learn what something is, but you don't know when to use it or how to use it. Right? I'm not talking about all the colleges. I know There are some NITs and IITs, they are premium colleges, exceptions are always there. I'm not talking about those colleges, but most of the colleges are like this. And number two, outdated subjects. Technology moves super fast in the industry, especially in AI and the data science. Many college courses do not keep up to date, right? So by the time you graduate, some of the things you learned in your college might be outdated by the time you come to the job, right? This is mostly happening everywhere. And the third reason, according to me, exams, right? The college exam tests the memory, not the problem solving. Our exams, right? Our college exams often check how well you remember that entire syllabus, right? Not how good at you are actually solving the given problem, right? This encourages the student to just memorizing the answers instead of truly understanding and thinking. And one more reason I could think of, subjects in the academics or the college are kept separate. So the real problem usually need to know from many different subjects. Something like you should know the math, coding and statistics and sometimes even a physics all mixed together to solve one real world problem. But in college often teaches them as separately, and for a student it is very hard to connect those particular dots. So these are the basic problems in our education system, no matter which college. I mean, most of the colleges I'm talking about, most of the places it's happening like that. So we cannot blame the colleges or the education system. Stop blaming them and start acting what you can do to fit in this particular industry, right? So being a student, what action items you should do rather than blaming the colleges to fill this particular gap and become truly ready for a job market, right? So the first thing is that understand the basics very deeply, right? Do not just learn the definitions that are part of the academics or the books. Try to truly understand why things work and how they connect to the real world problems, right? Always ask why. This is very important. Whatever the foundational concept that you are learning, always ask why until it clicks for you, right? And always keep learning outside of the colleges, right? Your college degree is just a start, right? The tech world is always changing, as I said earlier, right? Learn new things which are not part of your college syllabus, something like agentic AI or ML ops. Look for good online courses or expert guidance or expert resources, right? So keeping investment on learning is really good thing that you could start doing from your college. Learn by solving the real problems, right? So the best way to learn is by doing, right? It's not just studying and closing the book. You have to learn by actually doing it. For every new skill or a tech you learn, something like if you learn Python or if you learn new agentic framework, right? Immediately think how can you use this to solve a practical problem, right? So do not just watch the tutorials, try to build something unique. Build strong projects. This is a very important thing. Your projects are your resume, right? So don't just make simple projects. Try to build the things that solves the real world problems. Be ready to explain every single part of your project individually. Your choices, the challenges, and how do you fix them, right? During the interviews I'm talking about. You should be very well prepared with your projects. If you want to prepare it, you have to build very strong projects, right? And one more important thing you could do, find good mentors, right? Connect with the people who are already working in this field where you want to go in or where you want to target it to join in, right? So mentors can give you a very great advice and the guidance. Why? Because they are already experienced, they have seen something than you, right? So getting the proper mentorship is also a very important thing when you are under the graduation, right? Networking can open the doors to new job opportunities as well if you use the mentors very properly. With that being said, I hope this video gives you a new way of thinking and some clear action items to take, right? So let me know what you think of it, and if you have any questions or any recommendations for the video, please use the comment section below. I'll be uploading the more videos on data science and AI or the software engineering. If you like this channel, please subscribe ByAIte. Until then, happy learning. Bye bye.